Okay, we're on the air. Awesome. I think we're live. Um, all right, today is very exploratory in that we are going to explain something. So anyone who's been with Collector for a long time remembers when it was just a big folder of junk, but early on I made this documentation, and I have this thing called collector.pdf, which is designed to explain the flow of the experiment. So kind of, let me zoom this out a little bit. It's designed to explain where stuff is happening. So if you look at it, it's saying index PHP goes to this page. It tells you where each of the PHP files and how they're linked to each other. The problem is that almost none of it is true anymore. So this isn't how the experiment works anymore. So today we're gonna try to go over sort of where things are happening in the experiment, how to follow what the code is doing, and hopefully I can rope somebody into remaking this document correctly, but it might be myself, so I don't know. Part of this plan is to try to rope people into doing things that are needed for documentation, but we've yet to succeed on that. Okay, so I guess we'll start from the very, very beginning. How does this whole thing run? If you look in the folder collector, we have this nice separation of there's code, data, documentation, experiment. Almost everything we've talked about up to this point has been how to go into experiment and change stuff. But aside from experiment, the only files that you guys will have, I think, in this root folder are this htaccess file, which is a thing that I don't even really understand that Tyson and Adam Blake had programmed, and it's just basically a way to tell the server, don't let people who aren't us access the subject data and certain files. There's a README, which is what's generating this. So when you go to the collector page, the README is just what's generating this big thing down here. So GitHub has a nice formatting to make it look like there are headings and subheadings, and all that is if you open up this file, it's just how many hashtags are in front of each thing, tells it what level of heading. 1 means it's a super big heading, 2 is slightly less important, 4 is less important than that. So the README, again, not important stuff. So where it all starts is index. Index.php is the thing, I guess whenever a server loads a folder, it looks for an index file, which is a way to say here is what the actual page should look like. So whenever we're testing things, so if I go to my local host, this page right here, it doesn't show collector-index.php because the server knows look for index, and then wherever we're in this folder, load up the index file for that folder. So it's sort of the landing page for a folder. So the experiment, the whole thing starts at index.php. So that's what I'm going to show here. It's index. At the top, it's a bunch of nothing. It's just saying, hey, here's the license because the license I use requires you include it. And I guess the first thing we should talk about, okay, so I have 2 people here. I guess I should ask them. So there's Aaron and Courtney, who I think have their mics still on. Yeah. Okay, so say hi, people.
Hello.
Awesome. Internet reaching out. I think that was Aaron laughing in the back. Okay, so how deep do you guys want to go into the code? Because I'll tailor this to you guys.
Oh gosh, just whatever you want.
That's not an answer, Courtney.
Not helpful.
Whatever is best for the future generations of collector users.
Okay, that's a very long. That's like a Carl Sagan, like let's put this on the golden disc answer. Whatever future generations need. Okay, so good answer, Aaron. So I'll talk about. I guess this is the thing that's going to show up a lot. We don't have to necessarily go into very big detail what it is, but you'll see these around. These requires or includes. All these are is require just a way to tell the program when you run. So we're starting some PHP code up here. This is a big comment. And the first code that runs on index is we say require this file called the initiate collector.php. We run it on almost every single file in the program. And what this is doing is saying, go find the file inside the code folder called initiate collector and run that code. So if we look here, I can open it. So inside the code folder, if you look, here's collector, code, initiate collector. So this is just a way to get stuff up and running. Like, here's all the things that are required for us to really make the experiment work. Most of this is pretty well commented, so this seems confusing, but it just says this line has to exist to fix reading files saved on a Mac. The Mac saves files with different line endings in Windows. If we don't tell a program to auto-detect line endings, it breaks weird stuff. So on every page, we basically say read files and figure out if it's Mac or Windows file. Session start is really important because we talked about how almost everything goes into the variable session. Session only exists on that page if you run this function called session start. So we run it just to say, okay, open that session back up that you've created for this person, and then that allows us to save things to it and edit it and pull data from it. This stuff, not as useful, just talking about error reporting. This is like a clever solution Tyson made to figure out which folder we're in. We don't really need to look at it. And then we run some other requires. So one of the important ones is here. So on every page we say, start some PHP code, and now load or run this code here, read Mac files, open the session, figure out where the root folder is, and then we say, okay, require these other files that we use. So require file locations, which is in the code folder. We just go to here. So require this thing, which means when you're running code, stop right here and run all this code here. And all file locations does, it's just an easier way for us to keep track of how we're naming all the files. Before we had to hard code in the file names, and every time we changed it, we'd have to find the 20 places in the code we change it. So instead now we have one file here that says the variable up will denote this is how you go up a level in a folder. The variable data F is the data folder, and it's just all the way down the same stuff. So we're saying here's how we define all the names of the folders. So when we're running the code, we can just use the variable name here. So if we want to change it from code to codes, then we'd have to just change that there and then rename this to codes. And in theory, almost everything should work, but we're not going to mess with that right now because we don't make arbitrary changes, usually. Oh, so it broke down like, okay, so go to code, file location, so we go. So this is all we're doing. We're saying startup collector, start off all the stuff we need. So we say to show the file location so we can load up where things are going. Then we say load up the custom functions, one of the more important files. So custom functions is where we write functions that we use to make everything run. So it's a pretty big and scary file. Some of these functions I don't understand myself because Tyson wrote them. Tyson may not understand some of the functions I wrote, but they're generally just solve problems we kept running into. So if we want to add a column to a file, we can use this function here. And you'll see lots of functions that we call. Like, so the shuffling in the code, we just call block shuffle and we give it an input and we say this is the name of the column. And then here's all the code that shuffles things for us. So it looks big and scary, but for the most part, you don't need to mess with custom functions. You can write your own custom functions if you'd like. And then we say, okay, also run the settings, which is just saying go to the experiment folder and load up whatever settings we had set. So the file we've already looked at a bunch of times. So get the experiment name, the login locations, all the other little variables like the verification code. So that is pretty much initiate collector. That is saying when it starts, solve all these common problems that we have to solve every single time for us. That's the first line. We say require initiate collector, and that loads our custom functions. It tells us where the file should go, and it loads whatever settings the user had set. So this is the beginning of it. Everything. We just say, okay, do this. And we don't really need to talk about what most of the other stuff is doing because you don't have to mess with it. And all that happens on this page is we load up all the options you're seeing. So we load this up. You know, we counted the stuff in the conditions file. We showed you all the options you have. And what you do is, where is it? We're logging in. Where are we submitting to?
Or do you want to show, so maybe if you don't want to have that drop-down menu available for your subjects, do you want
how that works?
How to change that?
Yeah, okay, so you can change that in here. It's actually in your settings. So if you just go to the settings, under, where is it? Did it move? Debugging, no. Oh, here it is, index.php. So the starting page, it says show condition selector.
Okay.
Right now it says true, but if you just type false and then reload the page, that selector goes away. And the way we're actually doing that, so because we've already loaded up the settings file, I can actually show you exactly what we're doing. It's actually pretty simple. We say if condition selector is equal to true, then we start the condition selector. So we say a selector with the name condition. So if it's set to true to show it, then we start it that way. If it's not set to true, we start it with the class hidden on top of it. So it's actually still there on the page. We just say hide it. So if the selector is not equal to true, then hide the condition selector. So in theory, this doesn't even have to be equal to false. You can write, shoebox. It actually doesn't matter what we write. And this should still not show the selector. Oh wait, did I save it? Oh, that's weird. So write false, because that seems to break in a strange way, which I wouldn't have predicted, but it does. But that's the only change we're making. If you actually look at the code of the page, so when the selector is off, so if I hit F12 in Firefox, I can look and see that there actually is a selector there with all the options. It's just hidden from the page, so the user can't see it. So from our perspective, it's just easier to say, oh, hide that thing, but still don't change the code, like still generate it. We just make it a hidden thing. And that's actually how we solve most of our problems, is that we just say hide a thing when we don't want them to see it. So technically it's still putting it onto the page, but we just hide it.
And just looking at the show condition selector double equals true, the reason that it evaluates to true with a string is strings are converted to the Boolean true if they're not literally an empty string. So any word would be considered true, and I think in that case.
Oh, okay. So I guess this is the point where we can make a PHP code thing. Is the double equal says, so because PHP doesn't have types or generally doesn't enforce types, if you use this is double equal to something else, it'll say try to figure out if there's some way to evaluate the other thing to true. So like Tyson was saying right here, instead of saying false, if we said hi, what it would say is if condition selector is equal to true, well, if there was a string there, then the string would evaluate to true. So it's like true that there's some value set. But if you set triple equals, it means it has to actually be equal to true. And now it won't show again. So it's like a weird PHP thing, but I wouldn't worry about it too much. That's just a point. Whenever you look in the code and there's like a triple equals, it's because we're doing that. We're saying, don't try to figure out if the thing can be true. Just see if it's exactly set to the value true. Because PHP will evaluate all kinds of things to true. Like any number that's greater than 0 will evaluate to true. I think 0 itself might evaluate to true. But yeah, so the whole thing that's happening here is just we're making a login, and if you want to figure out like where the experiment's sending things, it's almost always you can look at the form that we're using. So a form is just a way to submit something to a web page. So here on the index page, we declare this forum, and we say class is equal to collector. The class names are just a way to change what it looks like. What you're looking for is this action. So action tells it where am I sending this stuff. So the form is meant for submitting. The action is equal to where am I submitting to. So here we say the action is equal to code folder login. So because if you look at file locations, code F is equal to this thing. So code /. So where we're submitting the page to is essentially this code/login, but because we have the variable names, we say echo the code folder login. So we're sending from index.php, the place the code is getting sent to is in code.
So
login.
what's the benefit of putting in that PHP code F tag instead of just typing code /?
Because we sometimes change the names of folders, and when we change them, it would be a huge pain to figure out all the places we use code. So instead, we just give it a name, a variable name, and then we go to file locations, we change it once, and then we rename the folder to whatever it has to be. So the benefit is more for the programming end. It makes it easier to rework how the program is set up. Before, every time we wanted to make a change, it just ended up being a huge hassle. And we'd think we'd make all the changes, and we'd find out later that part of it was broken because we forgot that we had also used it in another location.
Oh yeah, makes a lot of sense.
Yeah, I mean, it saved a bunch of time, but it does make the stuff look more complicated. But literally what we're doing is just this. We're saying action is go to the code folder, and login.php is the page we're sending the result of this to. And all they're getting sent are these inputs. So whatever input you declare is what's going to get sent. So input, we have one called username, which if you... So I like to use Firebug. Firebug does lots of nice things for me. So I can say inspect an element. If I click on this, you can see it shows me which code on the page is generating that thing. So the type is equal to text, and the name is equal to username. So on login, we'll be able to access username as a value for whatever they had set. And the other thing they're choosing is they've actually chosen this. So they've actually chosen auto as their value for this selection. So condition is a name. For condition, they choose auto. Even though they don't see it, the way we've programmed it, we basically say hide the selector, but start off by choosing auto as your option. So if they can't see the selector, they always get auto. But if they can see the selector, if I turn it back on. So right now auto is selected. So I choose auto for them, but they can overwrite the choice and say 6. So that's all that's getting sent from this page. We send a username and we send a condition selected. But when the condition selector is hidden, they get auto ends up being sent to the next page. So is everyone mostly with me? Any questions, concerns, confusion, things I've woefully misexplained? Silence is usually not a good confirmation.
You're good.
Okay, it feels like when you're TAing and you're like, everyone understand, and they look blankly at you. Like, I'll take your confusion as understanding. But I mean, yeah. So that's the beginning. I think I went a little too much in the code, but so we'll jump to the next kind of thing.
Nope, it makes sense. Good job.
Awesome. Okay, I love it. Bolster my confidence, but I don't know about my teaching ability still. So we're going to index. All that's getting sent from here is username and condition, and that is being sent to the most complicated file probably in the whole experiment, aside from custom functions, which is login. So login right now is doing almost everything. Login, by the time we're done with login, we've basically created what the whole entire experiment is going to be for all sessions of the user and set most of the things they are going to care about. But I'll kind of walk you through at the abstract level what you need to know, so you know like where you need to look if you want to change something. So again, in almost all files, we say initiate collector. So run all those things, set the file locations, load up custom functions so we can use them, and that all happens again. But from our perspective, it's nice and easy. We just say require this thing, and that happens. And then next, we say, okay, session, so that variable that we always want is equal to array blank, which just means get rid of anything that's possibly saved in session right now. And the reason we do this is that sometimes when you're linking between experiments, so if you have one experiment run, it creates a whole session for itself, and it sets up what that experiment is supposed to be. And then if at the end you link to another experiment, let's say the first experiment was 15 trials long and the second experiment is 10 trials long, this thing will run and generate the first 10 trials, but it'll also have trials 11, 12, 13, 14, and 15 from the first experiment loaded in. So you get all kinds of weird errors. Like I've run experiments where it's like 10 items or word pair learning and it's supposed to be done, and then they see 5 pictures of fish at the end because they were coming in from another experiment. So the whole reason we zero this out is to say get rid of anything that existed. If you have another existing session, trash it because we don't want it anymore. We want you just to be logged in fresh. These things are pointless. It's just saying pull stuff from the stuff we've initiated. The title, so if you look at login, I'll show you. So here's a really useful thing I like to do when I'm messing with login. It's a setting that I think most people don't take advantage of, but it's actually really good for troubleshooting and kind of seeing what's going on. Under debugging functionality, stop at login. Set that to true. So that means after you log me in, don't continue to the experiment. Stop and let me look at some diagnostic information. So I'll do that for now. So here I'll log into experiment. I'll pick condition 14 because the multi-session condition. Actually, no, I'll do an easier one. 11 is, I think, the magical condition. So here's what's happened is I've done all the logging in, and because stop at login is set, I pop up a bunch of diagnostic information. I'll show you how I'm doing this. So I can look at stuff like condition information. So if I click this, it shows me, here's what I have loaded for your condition information. Here's the condition number, the stimuli we should be using, the procedure file, the description of this condition, the notes. So I can say, okay, that all looks right. And then I can click on this and it'll show me information about the stimuli file we're using. So 0 and 1 are almost always blanked out because we want the number here 2 to line up with the first row in Excel. So here it says we're using stimuli file full stim. So we go to collector experiment, stimuli, full stim. So this is our stimuli file here we're using. And with this thing that we're using, close that. So of that stimuli file, position 0 we just set to nothing because there's no 0 in Excel. Position 1 we set to 0 because we don't want to read the headers here. And so the first position that has any data is position 2. And that says the Q is dog, the answer is cat, the shuffle is banana, high associates here. So dog, cat, banana, high associates. Number 3 is word pair, which happens to be the exact shuffle note order. Number 4, funny bone. So you can kind of check that, okay, it's loading in the stimuli as I want. So you can come down here and look to see, okay, 14 is the last one. It has this information. Okay, everything lines up.
Is this the place where it'll show it in the order that you have exactly as written in the stimuli.csv, or will it show you how it's randomized and shuffled?
It should show me how it's randomized and shuffled, but it might be doing it at a weird location right now. But this should show me the shuffled version, but I'm not sure if it is. Because I think Tyson might have moved around where the shuffling's happening, so this might be displaying before. But I can actually show you how we'll fix that and how we can kind of jump in anywhere and see what's going on. Okay, so this is all that we're doing here. We're saying, okay, stop at login, which means don't run everything. So now we can talk about the code at login, what's actually happening. And I'll show you what's generating all these kind of like nice clickable buttons. It's actually really easy to do. So one of the first things we do is say title. We call it preparing the experiment, because if you look on this page, the name up here is preparing the experiment when you're at login. You could technically change it to whatever you want, but it's just some variable. So an exclamation point. If I reload this page now, preparing the experiment, exclamation point. So that's how that's getting set. We require this thing, which I guess is worth mentioning at least once. So we say require code folder header. So we go into the code folder, look for header to see where that is. So this is the thing we're running. We're basically saying run this code up here, stop, and now run the code in header. And all header is doing is setting up the stuff we need to make everything run. So we're saying declare, whenever you're making an HTML web page, you have to do this, which is declare Who's calling me via Hangouts? Decline. Okay, so sorry. So I say, okay, here's a doc type, which just tells the web page, I'm going to be sending you HTML code. Then we declare, okay, here's the beginning of the HTML code, because as we mentioned, all PHP is doing is running stuff in the background and then sending out some code. And then we declare head, which is saying, okay, here's some information you need to make our code look right. We just tell, okay, this is the type of characters we're using. So that's all this is saying is we're using characters in this character set. You know, if you're using Russian characters or something, we change it to say Russian characters or whatever the correct character set is. Then we tell it, okay, use this CSS file. So the CSS file tells the page how to style the HTML we're sending it. So we're telling it, okay, the HTML file is in the code folder /CSS /go global. So if you look, code, CSS. So we're just saying, okay, include all the CSS we wrote to style it.
Hey, Mikey.
Yep.
For the one, so for the character set, I think that Tyson, if you remember, I had some symbols that weren't showing up correctly, and I think I had to modify that.
Right, that has all been fixed. All of it is totally solved now.
Okay.
Characters
so
will show up properly.
Change it when you have special characters.
Yeah, basically, Tyson. The reason we use this character set now is because Tyson wrote a function that reads our files and converts them to the correct character set, so that they'll display correctly. Before we weren't really controlling it. We were just saying whatever we read from the file is what we're going to show up, and sometimes they didn't match up. So Tyson fixed it, and we say we're using this defined character set, and whatever we read that you have, we convert it to this character set first before we put it on the page.
Right, so even if you've got smart quotes or characters with accent marks, it should all display properly on the browser now.
Yeah, so that's the weird stuff that was happening that should be not an issue anymore. But if it is, tell us. So yeah, lots of this stuff that seems complicated is because it was solving very specific problems like that. Like where sometimes you'd use like an umlaut and you'd get a little like diamond with a question mark in the middle, which is just the browser's way of saying we don't know what character this is you've sent to us. But that shouldn't happen anymore. So again, we're saying, okay, here's the CSS. This other CSS is actually only used for certain jQuery things we're doing. We'll talk about what jQuery is after. And then we say, okay, here's the script we want. So here's the JavaScript that should also run on every page. So the first one is we say, okay, run jQuery. So jQuery is a way of writing simpler JavaScript. It's an open source library, and it makes things a lot nicer and cleaner and easier to code. So we say, okay, first run jQuery, which is in code folder, JavaScript jQuery. So if you look, code, JavaScript, there's jQuery. If you try to read jQuery, you can't. It looks like this. So it's essentially a black box to us, but it works really well, and everyone on the web uses it, so we're assuming that they know what they're doing. So we say, okay, run jQuery, and then run our custom collector JavaScript file. Actually, no, we run 2 jQueries, then we run the collector one. So it's in JavaScript collector. It's got a version number, which we're probably going to drop soon because we've been updating and not changing the version number. So this is the file that runs all the timing. It does lots of the standard stuff that we want to do. So we might talk about that at a later time. But in theory, all you have to know is that the header is just saying, here's stuff we need on every page. Again, we need the character set, we need to load our CSS file, and we need to load this JavaScript to make everything run. And then the title is just saying, look for the variable title, which is set there, and put it as the title. And then these like divs, C-frame outer, C-frame inner, these just have to be there to center the content. So to make the page look nice and neat, you have to have those two because of the way the CSS works. But essentially, you don't have to think about them because they're just not really part of what you're doing. All they're doing is there to put the content in the center of the page. So that's header. So we just say, okay, run that stuff we need, And so I guess I can ask Veronica at this point. Veronica, how much code stuff do you want to talk about? Because we're getting very into code now, which I think was initially what you guys wanted, but I don't know if it's...
Veronica actually had to leave because her computer was having some troubles.
Okay, you can come back. Veronica? I think she started saying something.
Veronica had to leave because she was having computer problems.
Oh, I thought Tyson was telling me he had to leave.
Oh, no, Veronica did.
Oh, totally missed that message. Okay, so we'll just talk about in the abstract. Tyson can correct any weird things. All we're doing here is trying to make the username clean so it works. So we're saying username is equal to, you'll see this once in a while. Actually, this is the only page you'll see it. $__get. So before I talked about how things get sent to the page. So you said index sends username. So I'm back at index. It sends the username and it sends whatever was selected for a condition. In the form class, I said that what matters is the action. What also matters is the method. So action says this is where you send it, so send it to login.php, and methods is this is how you send it to login. There's two ways of getting or sending data the way we do it. There's get and then there is post. It's not really that important that you understand get because we only use get once, but I'll show you basically what get does. So if you look at the URL, so I've logged in already. It says login.php question mark, which means, okay, I'm going to be sending you information, and it just says username equals Mikey, ampersand, condition equals 11. So I could change this to Mikey2, and it would load up as I'm the user Mikey2. So this is what get does. Get basically says put the information we're sending in the URL. And then when you want that information back, you use $_get, and you call it like it's an array. And the name here that you're calling is just going to go to the URL and say, okay, I found this section here which has the value username, or which has the name of username, and it's equal to Mikey2. So the code is saying username is equal to whatever they set username to, which is, in this case, Mikey2. So that's all get is doing. It's saying look at the URL and get this information. Everything else we do is using post, which doesn't put the information in the URL. So post, it would look like, if we had to use post, it would look like this. So, you know, the URL wouldn't have the information baked into it. The only reason we have to use get here is because we're doing sort of this session destroying thing. But it's not important. All you have to know is this is just a way to grab information from the URL. So we grab it, and then Tyson's cleaning out characters that wouldn't be able to be written to a file name. You know, sometimes if they write their username as @ you know, the @ sign 3 times in a row or anything like that, you can't write a file name in most computers with those characters in them. So he's filtering out those characters so we can write their username as a file name. This is what we're talking about. So each login has a session ID. It's just a random string of characters that we give them, so we can keep track of, you know, if I logged in as Mikey 3 times, let's say I logged in once, did half the experiment, logged in again, did half the experiment, logged in a 3rd time and did the whole experiment. If I wanted to be able to pull out just the one login, you know, the time where I did all of it, I couldn't just use my username because I have the same username every time. So every time a user logs in, we generate a random ID for them. So all we're doing is saying, if the ID is not set, then pull it from the URL. If it's not set, pull it from the URL, or else it's a random string. So just either way, we generate some random string. Either it's set in the URL, so we do that if we're linking 2 experiments together. You would say, okay, send the username condition and also send the random ID so I can link the user from the first experiment to the second experiment. In that case, we want to use get to grab the ID. So if our URL had $ID equals ABC, then I'd actually find the ID is already set for me, so I'd use that one. If it isn't, then I just generate a random one. That's all it's doing. This is not all that important, so most of these headers you can just understand as checking for debug mode. So that's what this is doing. It's trying to figure out if you log in as the debug user. So we have the settings over here that say debug name is equal to something. So if we made test, then if I logged in with test, it would say, oh, to run this code in debug mode, because that user is the debug user. I think that's enough for login there. Here, checking info about this username. So again, these headers will kind of tell you, do I care about this information? So here, or is it long enough? We had a problem of people logging with 0 string username or 0 length usernames. They just type nothing, hit enter, and would let them log in. So we just enforced a minimum of it has to be 3 characters or longer. So that's all we're doing is checking if it's 3 characters or longer. If it isn't, we send them this error that says login must be 3 characters or longer, and then a link back to the login page saying try to log in again, or to the index page. Here we can run a check, so to check if they're ineligible to run the experiment. And all we do is say if check eligibility is equal to true. So check eligibility is actually just in the settings file. So under, I think it's mturk mode, we have check eligibility. Right now it's false, but if we had set it to true, then we would have done this. We said include check.php. So include is just like a require. The only difference is that with an include, if it can't find this file, it'll still keep running the code. With the require, if it can't find the file that it's looking for, it'll stop and say file not found. And what we run is check.php, which is not even really worth talking about. All it's doing, I guess I'll tell you what check.php does from your perspective that you'd care about. If you go to experiment, there's a folder called eligibility. You can look at this example text file. I'll open up in Excel because that'll be nicer. So this example file just has this. It has worker ID as the username or as a column header. And then these are the user IDs that we're not going to allow to log in. So right now, Batman, Robin, and the Joker can't log in. But the real reason you do this is that on Amazon Mechanical Turk, after you do a batch, you can download a summary of the entire batch that you ran, and there's a column in there somewhere called worker ID, and it has all the mturk logins of the people who ran that particular batch. So what you can do is just grab that file, whatever it is, and drop that file into your eligibility folder. And you can have as many files in here as you want, so you don't have to combine them in. You can just say, let's say you run an experiment using the same materials in 3 different Amazon mturk batches. You can go to each batch and say download all, the summary of all the workers, and then do that for each of the 3 batches you ran. Drop all 3 of those files in eligibility, and the program will know to load up every single file it found in here and find all the worker IDs across all the files. And then if somebody tries to log in again with that same user ID, it'll tell them you can't do this experiment. So the main reason you do this is to make sure that you don't run somebody who's already seen these materials or who's already run a version of this experiment that would taint them for the next version. So this is a nice, easy way to do it. You would just, if you had taken the steps and, you actually downloaded those batch files from mturk, you just go into your settings, which the settings file is an experiment, and you'd say, true, check the eligibility of everyone who logs in. And then this eligibility folder, you'd have a bunch of different files from all the batches you've downloaded. When someone tries to log in, the program will first check everything to see, have they done it before? If they haven't, it'll let them log in. If they have, it'll say, sorry, you have already participated in this experiment. You're not eligible to participate again. So that's all the check is doing for the most part. It's saying, check if you already have this user in this experiment or in some list of excluded workers. You can set up your own list if you want. Just have a column in there called worker ID, and you can set up users who have tried to cheat in the past, users who you think shared their codes with other people, whatever it is you want, whatever criteria you want to use, you can block workers from logging in to your experiments based on those criteria. So that's all we're doing here is run that check. Here's how we do multi-session experiments now. All you have to really understand is this. If you go into the data folders, there's a folder called... Oh, it's not created yet? Oh, probably because the person is logged in. Well, there's a folder we call, I think it's just called JSON files. So I can look at file locations. It's called JSON_session. So whenever somebody finishes the experiment, we add a folder called JSON. Actually, don't do this. We add a folder called this, and it'll have that username. So you'll have something like you have a file like this, and it'll have one for every single user. And these files only get written for users who finish at least one session of the experiment. So the way we do multi-session is we just say, check if a file exists for this user. So go to the root folder, then go to the data folder, then go to the data subfolder. So if they're logged in as debug, it'll use the data subfolder. Then go to the JSON folder, and then look for a file called username.json. So this seems complicated, but literally we're just saying, get to the JSON folder and see if there's a file for this username. And if there is a file, so if this session file name is equal to true, so we found a file for this username, then we load up the, we basically read the old session file and we load it up. And then we just keep them running. So this is all that's happening here. Session file name is equal to true. Wait, this, yeah. So session file is true. That goes up to right there. Oh yeah, then we have this else. So we say, if we have a file for them, they've already completed a session, do all this stuff to load up their session, or else their session number is 1. So anyone who doesn't have a file already should be doing session 1. Otherwise, we just load up whatever data they had when they finished last time, and then we just continue them. So this is how we handle running multi-session experiments. Error checking code, most of the stuff is probably people can kind of blow past. Let's see. Yeah, this stuff is pretty well commented if you want to see what's going on. So we have, does condition exist? We say, if file exists, root folder, experiment folder, whatever the conditions file name. So if that's false, that means we didn't find a condition file, and we generate an error. We say, use this variable errors. It has 2 values. It has a count and a details. So every time we find an error, we increment the count. So we say plus plus. So count an error. We start count at 0. And then the details means submit, save the details of this error. So we say no conditions.txt found. And that's the error. So we say 1 error, no condition found. Does the condition file have the required headers? So we say errors is equal to, I wrote this function called keycheck. So whenever you see a weird function, copy it and look for, go to custom functions and search for that name. It's probably in there. So you can actually see what we're doing for any of these functions. But all it is, it's a function that it's really good for. I can give it a file. So here I say, this is the file. This is the column I'm looking for. This is Jeff By. Answer that later. So it says, here's the file. Here's the column I'm looking for. This is the thing that holds all the errors. And this is the name of the file. And we run this function, and if it finds new errors, it reports back. These are the new errors. If not, it just reports back the errors we already had stored. So that's all I'm doing. I'm saying, look for these columns. So you make sure it has a column called number, a column called stimuli, and a column called procedure. That's all this is doing. Here's how we choose condition assignment. So we just say if it's auto, do all this code, which figures out which condition to give them. If not, just give them whatever they selected. This is just loading the condition info. So at this point, we know what condition number they are, because if it's auto, we've set to some number. If they selected one, we gave them that number. And here we just load the information about it. And I guess this is a good point to show you how I'm doing all those nice. So at the very bottom, I say if stop at login is equal to true, and I do all these things called readables. So I'm going to turn all these off and show you what's actually happening here. So I just made these all comments, and I'll show you how to use readable to diagnose most of the problems you're going to have. Let's see, where is it? Okay, so right now, I say for each condition as a condition, if a condition number is equal to the condition number, then session condition is equal to that condition. So this looks complicated, but actually you can do this. So I'm going to go back to the web page. So I turned off all those error thing or those boxes we were using before. But here's what you can do if you want to find out what's going on in the experiment. Readable is a function, so it's in custom function. Readable is a way to look at arrays, to figure out what's inside of them, because almost everything we do is in arrays. So if you want to see what's actually happening inside of an array, like you did something to it and it's not working, I would use readable to figure out what's the current state of this array. So right now we can say readable, and we just give it the name of an array. So conditions is an array that we loaded up, and then I can just do that. So if I run it in the simplest case, I just say readable some array, and it gives me this. So it just says untitled array. If I click on it, it shows me here's what it's loaded for that array. So in position 0, there's a value for a number, stimuli, procedure. So you can see we have positions for all of the different conditions that are possible. So this is just showing us what happened when we did this. We went to experiment, and we loaded this file here called conditions.csv. So we loaded this file, and this is what we loaded it into. So if you want to see where that happens, just copy the variable name. So I do this all the time. I just say, where did that stuff get loaded? I copy the variable name, and I just search through the file for where that was declared. So conditions, where did I grab the conditions? Oh, here it is. Conditions is equal to get from file up experiment folder condition file name. So this is just me saying this variable conditions is equal to whatever I read from here. So read this file and save it as conditions, which is what I did. And when I saved it, I got this. So I got this array, and this is everything that got loaded into it. And then if you want to see at the end, so if I go down here, so what I do is I say, okay, go through each of the values of conditions. So it goes through 0, 1, 2, and keeps going for each of them. And for each one it says, so conditions as a con just means go through each value in conditions. In this case the values are just 7, 8, each of these positions, and set it as a variable a condition. And I'm checking if the one I'm checking right now, so for each would say, okay, 0 is equal to a condition. So if a condition number, so a condition number is equal to the condition number, which was set above. So let's say we choose condition 1. So I'd say go through all of conditions. So it's going to go through this array. It's saying, okay, check here. Is that number equal to 1? Yes, it is. Right? So condition a cond number is equal to the one I selected. Then what I do is set inside of session, I set a thing called condition, and I set it equal to this one that we loaded here. So that's all I'm doing. And I say found is equal to true because later this tells me that I found a condition file that matches up to what I selected. And break just means stop checking, like I'm done. I found the thing I need. And then at the end, I can say, okay, what actually? So I want to see what got loaded. So session condition, I want to see what that is. I can say readable session condition. So show me what is in the condition that we're looking at now. So I had all of them loaded. Then I tried to match the number I had selected. If I matched it, I saved it as session condition. So if I do this on this page here, so we have two things called untitled array, which is why I do this in readable. So readable, if you pass it just a condition number, it calls it untitled array. But if you put a comma, you can also give it a name. So you can call this all conditions. And then if you put a comma here, you can call this one the selected condition. Save that. Now this one says all conditions selected. So I click on this, I can see it's numbers 11. The stimuli file is this. And the reason it's choosing 11 is because the condition is 11 up here. I could actually change that to 12. And the program will run and it'll find condition 12 now, which if you go down here, it's looking until, like, does this match the number I chose, which is 12? It doesn't. It doesn't. Doesn't. Okay, here it is. This matches. So save all this stuff as a condition. So save all of it as the session condition. And that's all we're doing. And that's all we're just choosing select conditions. So readable is probably the most useful tool you can possibly have for debugging stuff. Readable will tell you what does an array look like, and if it doesn't look like what you think it should look like, then that's how you can know where your problem started. So up to this point, we know what the username is. We know their random ID. We know what condition they selected, and we've loaded that information. And then we just do a bunch of error checking. So here, I said that we set found is equal to true. The reason we set it equal to true is because if found is still equal to false at this point, that means we never found the matching condition. So we generate an error, so we add one more to the count, and we say, could not find the selected condition. Here I just make some path names so I can use. So I say the path to the stimuli file is go up a level, go to the experiment folder, look in the stimuli folder, and then whatever session condition stimuli is. So you can turn this one back on to look at it. So we go to session condition, stimuli is equal to this file. So this is just a way to get to the file name. It's how do we load the stimuli file. This is how we load it. Same with the procedure file. We go up, experiment folder, procedure folder, and then whatever the file name is for this condition. So if the file exists is equal to false, that means so if we didn't find the file, generate some error, check these columns exist in the file. So for some reason, you don't want to have to require the answer column, you can come down to here and say, make that a comment so it won't check that you have to have an answer column. The same thing we do for the procedure file. We say, could we find the file? So if the file exists for the procedure pathway, if that's false, generate an error saying, hey, we don't know where your procedure file is. We're checking columns in the procedure file, so we want to make sure you have to have an item column, a trial type column, a timing column, and a shuffle column. Find all the columns that hold trial types. This part's really confusing, but if you just understand that this is all we're doing here, we're looking for all the columns that hold trial types. So we're looking for trial type, post 1 trial type, post 2 trial type, post 3. So we're trying to figure out how many post levels you use, essentially. And this is a big bunch of code. That's all it's checking for. Checking that all the post levels have the needed columns. Again, just checking stuff. Here we're checking that all the stimuli, wherever there's an image link, that it points to a file that exists. Are you talking?
Oh yeah, so I'm here now.
Okay, Tyson.
I'm available for questions.
Alright, available is good. What else should we talk about here? This stuff, skip, not important. End of error checking. Here's what matters. We load your procedure file. So here's kind of how the experiment's built. Right here is where the whole thing happens. And Tyson can chime in on some of this stuff. So we say load a procedure file. So we know it exists already because of the checks we did. So we load that file. Finding keys equal to true. Don't worry about it.
Yeah, currently this isn't technically the end of error checking. We have a little bit further down, but these are checking for errors within the specific trial type. So you can consider the error checking section above as mostly for the big condition, stimuli, and procedure files.
Actually, we're talking about this. Here's what we'll talk about. So this is doing a bunch of stuff, but what it's trying to generate. So the reason we do all this is to do this one thing at the very end. So here's, we're checking the trial types, so where are all the trial types being used. So here's where we create the experiment. Let's start. We're 400 lines in, and now we're actually making the experiment. So the key to understand the sequence of stuff happens. We load the stimuli file, and then we run shuffle on the stimuli file. So if you want to see what this looks like, you can do this. You can say, so here's why readable is really useful. So right here we load the stimuli. So say, so show me what the stimuli looks, and we can call it.
And if it's helpful, I have that function display 2D array that's good for get from file results.
Yeah, which we might use, but yeah, we'll show it after because there's weird problems that I've run into. Okay, so here I'm saying, okay, I load the stimuli, and now show me what the unshuffled stimuli look. So before I shuffle them, show me the stimuli, and I can see, oh, okay, dog Old Yeller, dog Beethoven, dog Lassie, cat Garfield. So here's your, it's going like that. If I want to see how it's shuffled, I can just say, show me, run readable again after the shuffle function. So cat Scratchy, cat Garfield, cat Felix. So what is it? Yours is display.
Yeah, and it's not case sensitive, so that's fine. But it only accepts one parameter.
Yeah, so I was gonna drop it.
Or yeah.
So Tyson has another one that's nice for two-dimensional arrays. It'll do this for us. So this will show you, here's what was loaded in. So in position 2, we have dog, answer, our Q, answer, shuffle, shuffle 2. And then it'll show you the second version, which is here's what happened after you shuffled it. So if you want to check that your shuffling is working correctly, you could just add a display 2D array after you shuffle it. And that would show you, okay, here's what's happening. Let me zoom this out a little bit. So mouse Mickey, mouse Itchy. Run it again. Okay, that's how it's shuffled. So every time I run it, it'll just do another shuffle. So you can check to be like, okay, it's doing the things I expected it to be doing. So that's a nice way to kind of check that stuff is happening as you wanted it to. So we load stimuli, shuffle stuff, and then we save it as stimuli. We do the same for procedure. We load procedure, then we shuffle it. If you want to see that's working, we can say, show me what procedure looks like. So here's your procedure after it's shuffled. There's again. Oh, there's no shuffling because they're all set to off, so that's good to know. It's like, why is these item numbers not moving? So because procedure is not being shuffled, this will be the same every time. It's a nice sanity check. Let's not worry about adding columns. Save the procedure. And what's coming out at the end of this is this variable that is very important. Session trials. So if we do a readable on trials.
Right, because the display 2D array wouldn't work on trials since it specifically only works on arrays that are not deeper than 2D.
Yeah. So if you want to see like what is the whole progression of the experiment going to be, if you just go to, I just wrote this as trials. So at this point, the whole experiment is set. It's all in trials. So we load it, and it shows you, okay, the first, 0, we always set at 0, so we start trial 1. Trial 1 would use this stimuli information. this procedure information. These are all the response keys that are going to be filled in later. Trial 2, use this stimuli, this procedure. So this is just a way to kind of quickly say, like, okay, what's going wrong in my experiment, what's happening, get an idea of how the flow is going to work. So that's all happening at that point. So the real important thing is being able to use readable to just intercept stuff and show you what's happening, which is why I do this. So we turn these back on. So here, if you look at the, so here's just how we send errors to the page. Not really important. We just go through the errors array and check if there are any errors. If there are, we display those error codes. Okay, if due demographics. So this is back to where we get to flow. We're like an hour out of what's happening in the experiment. So if in the settings, there's a little function here, or what's it? At the top, due demographics. By default, we leave it to false. But if that was set to true, what's happening is at the login, we set the link for the next page. So if due demographics equal to true, we send them to basicinfo.php is going to be the next page. If it isn't, then we send them straight to instructions. And then the way they get sent is this. We just do loading form, action is equal to wherever the link. So we're sending them to the link we've determined up here. And the method is equal to get. So we're getting some data on the next page. Actually, what are we're not using any data, right? We're not sending them any data, but we use get still. It doesn't matter.
Right, I think get's just a little bit faster, but it ultimately doesn't matter in this situation whether or not we use the post or get.
Yeah. So we're saying, okay, send them to this page or that page. So this is kind of the first point in the experiment where things branch off, where it's not exactly set order. So they go from index to login, and login will either send them to basic info or to instructions. So if you go to basic info, so these are now, we're through like the most complicated stuff, I think. So basic info does the same thing, initiate collector, do the header again, set the title of the page. Here's where we ask all the demographics questions. So we just say there's a form here, div class equal to field, and you can basically look at these and just copy the questions to generate your own questions. It's actually pretty simple. And what matters is the forum, the action is equal to basic info data. So that's how you know where we're going next. So, they're answering these demographic questions, and the place they're answering them to is basic info data. And the method we're using now is post, which means don't put it in the URL. So up here we have, the URL encoded version of the data. Here instead we just say send it using post. And if you look at basic info data, it's another really simple page. We just say, okay, because if we require all the things we need to get started, the data is equal to the username, their unique ID, plus whatever they sent to us from basic info. So that's all the data. We're saying grab all this and set it as the variable data, and then write data to the file name where the demographics should be sent to. And here, because we don't send out any HTML code, so there's nothing being displayed or echoed, there's no header, there's no footer, we just say you can use this little method that says header locations equal instructions. So from the server side, what happens is when they go to basic info, it tells them send your data to basic info data. The data gets here, we add the username and ID, we write it to the file where it should be going, and then we immediately load the instructions page. So this is what basically you never see this page. The server sees it, executes this code, and says, oh, I should be sending them to instructions. So then it loads, or sends you this stuff from instructions. So now the two sort of converge again, right? The paths could be you go to basic info or you go to instructions. So you see basic info just asks questions, records the data from those questions, and then sends you to instructions anyway. So both paths end up at instructions at this point. The only difference is One of them has recorded some information about demographics, while the other hasn't. Here again, we just initiate collector. So start up all the stuff we need, set a title. What else to talk about here? Okay, so the form, again, like the way everything works. So there's some form. The action is equal to go up a level, go to the code folder, and go to trial.php. So the reason we have to go up a level is because instructions is actually in the experiment folder. So we can't just say, go to the code folder, because what the server would do is look inside of experiment for a folder called code, which actually doesn't exist, and then it won't be able to find code trial.php. So instead it says go up one level, so go back to this root folder here, then find code, then load trial. So that's all that's happening here. And trial, I think Tyson should explain, because I think Tyson is more familiar with what's going on with trial than I am. Also, I'm getting really thirsty.
Okay, I can give it a try.
Tyson, you should screen share. There you go.
Right. Okay, so is that on me now?
Yeah, you gotta make your text a lot bigger.
Okay, let me just open trial.
Probably still bigger.
Okay.
I don't know if it's my bandwidth or what's going on.
How's that?
Yeah, I can mostly read that.
Okay. So starts off with just initiating again, and then here, these equal ampersand signs basically mean that these conditions are, or these variables are links to these variables. And the reason we do that is sometimes it's helpful where we want to change the really big variable, but we don't want to type the entire thing. So we make it so that if we change Q here, for example, it will update the variable that is actually session trials 3 stimuli Q. But if you need to echo out the Q, it works just the same. These are just how trials work in the trial types. They'll be using these variables. And then we have this function here called extract trial. Basically, this will find what row you're on in the procedure file, find out which post trial you're on, if you're on post trial 1 or 2, or if you're on the first trial of that row, and it will pull out the relevant variables from that row. So, for example, if you're on the first trial, you're not on any post trials, then it will know to ignore the columns that are like post 1 trial type and post 1 timing. And it will also create the extra variables that you'll see later in the trial types. So, for example, if you have a text column in your procedure file, then after extract trial is run, you can get the text of your current trial just like that. So if you were to say echo text, then whatever's in your text column will end up as a variable, and you can use it straight after.
And so it would also know then if we're like, let's say I'm on post 2 and there's a text column, would I still just say echo text and it would know, okay, well, you're on post 2,
right?
So you should get the post 2 text column. What do you say, text?
Yeah, you would just say text. So the reason we do it that way is that we want post trials to be able to use trial types just like regular trials. So if you want to use the instruct trial type as a post trial, then you can, and it'll still work even though instruct is using the text variable. So this just sort of, normalizes all your variables so that the trial types know what bits of data they need to work with, and they don't have to worry about figuring out post trials in their own individual code blocks. So text will be like the current post trials, current row, just exactly whatever you're working on at that moment. And the way that it converts from column headers to variable names. I think we've talked about this before, but it does something called camel case, which basically means that all the spaces in a word are pulled out. So if you had something that was like minimum timing with a space in between, it will just take out the space and put the words together. The first word will be all lowercase, and the first letter of each extra word will be uppercase. So for example, a column like this would later become something like this. So that's just how this sort of translation from column header to variable happens. And then
yeah, I'm trying to see on mine like where's the next like relevant.
Well, here, so at the end of our big trials block, we put on this extra row which just says that the last item in our experiment is experiment finished. And so if we reach that point, then we know to go to done.php. But the more complicated section right here, so this, if you remember, the get variable lets us know what was in our URL request after the question mark. But trial.php works off post variables, which means that the data we're sending back and forth is actually hidden from the browser URL. And basically we say if we have any data in our post variable, then we're going to do some extra code here. And mostly that involves recording the data and then refreshing the page.
We get data in the post variable. When would that happen that there would be data there?
Currently, we get it straight off the bat from we post from instructions. So looking at instructions, we have a form here, which its method is post, which is why it's showing up in our post variable. And since we're posting it to trial, as soon as we get to trial, we have all the instructions data, which is things like how many times they clicked on the various options. And since we know that current post is only -1 when coming from instructions, we know that this particular post data should be written to the instructions file. And then every other time, we have a little bit more complicated procedure to record our data. But basically, we check what trial type that we were just on, which tells us, basically what submitted data to us. So if we were on the test trial type, then if we have this trial type here, well, we'll know to check that trial type's scoring. So right at login, we read all the trial types that we're going to use, and we also checked if they have a custom scoring file. And if they didn't, we just paired that trial type with a default scoring file. So if we have data from a trial type, then we basically just load its scoring file, which most of the time is just the default. And then once we have that scoring procedure done, which, for example, looks like this. This is the normal scoring procedure that we do after every trial type. Basically, we just take all of that data in our post variable, correct the response and see if it matches the answer of that trial type, and then measure the accuracy. And then we simply add that to a growing variable called our response variable for the current trial. So we're not recording data after every single trial type. It's actually after every row in the procedure file. So you're sort of collecting data through all your post-trial 1, 2, 3, and then once you're done with all your post-trials, you get sent to next, and next will actually do the job of recording it. So that's basically this check here. So we say, place our data into a variable so that we just can hold on to it and look at it later if post-trials need to look at it. But then we just sort of scan the procedure row that we're on, and we keep on trying to extract trials. And if we can't extract the next trial, then we just run that trial type. But if we have no more post-trials to extract, then we tell the program not to go through trial.php again, but actually to go to next.php. So we sort of override this next with next.php rather than trial.
Hey,
And sorry, what was that?
Hey, so I just had a question about, so you said that it doesn't actually write the data after each trial type. So like
Yeah.
if you make a response, like so if they answer a test question like wrong, for example, and then like if you're doing like conditional like feedback, so if you're only giving the post trial like if they get it right or something like that, there's no way to like record that that happened other than seeing the results for that. Does that make sense?
So if you're asking if the program can check what the data was, it's still in current trial. You're writing into a variable.
So I think it's good to talk about the difference between writing versus, so there's stuff in memory and then there's stuff that's actually like written in a file somewhere. So what we're doing here, if you look at, right, so we say if its current post is -1, we do the write data through the instructions, or else we do here. So say if current post is 0, we have this thing that says keymod is equal to blank, or else keymod is equal to post.currentPost._. But really what that means is, let's say we're on post 2, so keymod would be equal to, it's camel case, to be equal to this post 2 underscore, let's say like reaction time, or no, just post 2 underscore. So keymod is something we're figuring out every time. We're saying what post trial you're on. If you're on a post trial, then save a value for this thing we call keymod. So let's assume we're on post 2. We'd have post 2 underscore something. So the keymod is post 2. We'll just leave that there for now, so to remember to get rid of it. And then down here, so current trial response. So current trial again is just pointing to trial type. Like, I guess I'll show you back from the login. So if we look at what's happening in session trial, so current trial just tells us which number are we pointing at. So let's say we're pointing at 3, like Tyson said. So current trial points at 3. So we say current trial response. So we say 3, go to the response array, and then we say the response is equal to place data. So place data is a little function we wrote, which allows us to say take whatever we got. So if we were on our scoring file, where is it? Scoring. Okay, so with scoring, right, we're writing everything to this variable called data. So we say data accuracy is equal to acc, and data strict accuracy or data lenient accuracy is equal to some value. So we're storing all this stuff in a variable or an array we're calling data. What we're doing is actually saying go to the current trial. So in this case, we're talking about 3. So go to 3, go to the response array, and then place data. So place the data that we collected in the scoring, because we ran the scoring right before. You say we require the scoring file. So that means run the scoring file on the data we've just collected, and now place that data that we collected inside of their current trial response. So place it here using the appropriate keymod. So when you're on regular trial type, you're not on a post trial, there's no keymod before, right? So it would just be a blank, like the 2 quotes we say it's up here. It shows it's just 2 open quotes, which means don't put anything there. When we're on post trial, we add this little keymod. So what essentially happens is when we're writing the data, this place data function right here says if we had like data, let's say strict accuracy, so our scoring had created that. When we place the data down, what we end up writing to is current trial response, and then we do this. We say keymod dot whatever the name was. So in this case, let's say we're writing strict accuracy. So we do keymod dot strict accuracy. So this stuff is stored in memory. So you think, like, let's say we're on post 2, what we'd have in memory is this, we'd have a value.
So are you basically just saying that even if it isn't writing to your output file, after each like subset of the one trial line, it's all stored and it's all accessible if you wanted to write it?
Yeah, because we never really look at the output file again. We just write it after the end of each line, but we're always pulling from the memory.
Okay, so you're just saying that like you'll have all the information despite it just like looping back on itself until it writes.
Yeah.
Right. And that's we store the writing process into the end because we write one row at a time, and all of these post trials are put on the same row. So rather than writing half a row and then overwriting that, we just store all of that. But in terms of what the program uses to figure out what you've done before and what you should be doing next, that's all in memory, and it's all updated immediately. It's just a matter of if you're sort of scanning your output files, trying to watch, as you're testing it, if you're going through and you're just watching it come in line by line, that's why it wouldn't come in right after a trial if you have a post-trial you're waiting for.
Yeah, so you could write, like, in your feedback, you can imagine, you could write, like, last RT is equal to current trial, response, and you can write post. Let's do this. So how do we figure out where current post? So let's do last post equals current post minus 1. And we do post dot last post dot underscore dot RT. So that would basically get you back to whatever the RT was for the last trial. So you just say, every time we run a feedback, if for some reason I want to tell them, okay, you took this long on the last trial, if there's always a post, you can say, okay, it would basically say, if you're on post 2, it'd be able to tell you how fast you went on post 1. So it would pull up, okay, we're on post 2, subtract 1, so give me post 1, that's equal to the last post, and now the last RT value is going to be whatever the current trial is, response, post 1 underscore RT. So you can still access all the stuff you need. So kind of knowing how we're placing it, I think will make it easier to do that kind of more complicated stuff, which most people probably don't need to do, but when you need to do it, it's very nice to know how to do it. But does that make some sense at all? I don't know. I'm never sure how much sense I'm making.
I think it makes sense. It's starting to get like a little murky, but that's maybe just because we've been at it for a while.
Right. So just sort of summarize this area. So right at the top, basically we find out which columns are relevant just to this post-trial. And then if we have data, we figure out where to store it and possibly where to write it. But these big chunks are just, there's stuff that you wouldn't really need to edit to change anything, because it just says that if I have data, then write it and add some prefixes to let me know where it came from. And up here, it's just setting up the aliases that you'll be using. Like, it'll tell you what your current queue is and your current answer is, but it'll update in figuring out what specific queue you should be using depending on what post-trial you're at. One thing that's sort of interesting up here is automatically, I actually do a little bit of code to modify the text variable, which comes from your text column. So basically, it finds that column, and then it does a search for these specific words. So this is $Q and $answer, and it'll actually swap that with the actual Q and answer for that trial type. So say, for example, that your text was something like this. And this was your instruct trial type, or something like that. Then rather than saying the Q is $Q, it will actually look at the stimuli for that. So if you said that the item was 2 and your second row in the stimuli file and dog is the Q, then this $Q would be replaced with the word dog. So you can use this text to sort of add a little bit more information, and if you want to do something complex with it, you can do this sort of replace, using a function like this, which will let you make your text a little bit more dynamic as you go through. So if you're surprised that your text is coming up weird, I'd be surprised if you accidentally put $Q, but if that did happen, this is why.
Let's see, what else here?
Perhaps you can explain how the new session stuff works, since that's your area, Mikey.
How the new what?
The new session items get identified and next trial, this part here.
Okay, let's see. So, yeah, so Tyson basically said the trial is looping on itself, and that the trials are each submitting. Actually, no, Tyson, we didn't explain where the trial types even show up.
Right. So right now we're just doing all sort of the pre-work, setting up the essentials for running the trial types later. So first we just need to store any data if we have any, and also set up the variables. I guess basically down here, I guess on mine it's around line 130. Then we find out how specifically to define the instructions for this trial type. So if we're on the trial type of instruct or test or copy, what does that specifically mean? So we look at the trial types variable we set in session, and we find out what file we have associated with that, which is basically looking in our code folder, in our trial types folder, for the file with the name of the trial type. And then once we find it, we do a couple complicated checks where we basically use another include to simply pull those instructions into here, and we put that inside a form here. So we include this, but we put it into a variable rather than directly spitting it out. So for example, in your trial type, if you say echo this message, then the content of this message is stored in this variable called trial contents here. And then we open our headers, and then we open a form here, which is our collector form, and we set post to is actually just to trial, so it's posting to itself, and then we just spit out the contents inside this form. And the reason that we do this is because we're actually capturing reaction time on every single trial type, and we always want to make sure that the form has this class that we set, form class, which sort of helps the program tell if it's user timed or computer timed. But we didn't want to have to write all of that code inside every single trial type, because that'd be a little complex, and it would be hard to explain that if you're going to modify something, make sure not to modify this, but this is okay to modify.
Yeah, so it simplifies what the trials have to look like. The trials before used to have to include all those weird things that you shouldn't mess with, but now the trial types don't include that stuff. They include, like, if you look at Q, it's really simple. It just says, here's a style, send out the text, and then show the Q in the middle of the screen.
Right, and these files, it's absolutely fine to modify these things. Probably the one thing that you should keep constant is that your submit button should have this ID is form submit button, because that's what we target when we're determining whether or not to hide the button or lock it if you have a min time. So if you have a submit button, remember to sort of use this sort of HTML for it to set its class and its ID. But everything else you can delete, you can replace, you can do whatever you want with it. So at the top of each trial type, we usually have a line that says comp time is equal to either a number or to the string user. That is how we let each trial type set its sort of custom timing, or its default timing, so that if you put computer in the timing column, then it will just know to use the comp time from that trial type. But everything in here, if you deleted that line, I think it would actually work fine. although it's good to have defaults. But you
Yeah,
can...
it'll default, so I think the experiment has its own default timing. I think if it doesn't find one, it sets it to some other number.
Yeah, that might actually be in settings or somewhere, I'm not sure. But these trial type files should be really simple so that you just have to look at the things that you want to change. And basically the whole point of trial is to build the shell that sort of holds your trial type, but it does all the complicated stuff for you that you don't need to think about on a trial type by trial type basis. So, recapping, the top of the page, we identify all the variables you can use, like, $Q, answer, your text. If you have other columns, we'll find those for you as well. And then we figure out which trial type you're on, and we identify the file that has the instructions for that trial type. And then we open a form which tells the page to post the data to itself so that we can record the data once they've reached the end of the trial type. And then we just spit out your contents right in the middle of that form. So if you're looking at your trial type file, you can sort of have this understanding that all this is taking place inside the context of a form, which is inside all of our our C-frame divs, which have their custom CSS, which is why in the experiment, things are appearing more complex than just the trial type, like you have your automatically centered text and all that.
Yeah, so when you're actually on a trial type, if you do, you look at the output, like in Firebug or something that will read the code for you, you won't just see the stuff that you created here. You'll see the stuff you created is wrapped in a lot of other stuff. And that other stuff you can think of is just sort of the guts that make the program run and do lots of automatic things for you, like center text and record reaction time. And mostly, it doesn't get in your way. Like, it pretty much just... it functions on its own outside of what you're trying to do in your trial types. You don't really need to worry about it or mess with it much. And I think Tyson mentioned this somewhere before. It's actually pretty simple how multiple session experiments work. So after we score the data and place it, there's this one little snippet here. It says, so right now it's line 102. This might change whenever you're watching this. And it just says, if we hit a new session, then the experiment is over. This means that we don't ask final questions until the last session of the experiment. So all I'm doing is, when you make your files, so I can show you one that has a new session in it. So experiment procedure, I think one of these is called multi-session. There it is. So you have these little new session markers, and they go in the item column. So all we're checking for is saying if the string to lower version of item, so basically ignore whatever casing the users put in here, in case they forget to capitalize the S. I don't want to make it not work. So I say change this to all lowercase. So whatever casing they had, override it to lowercase. And now if that thing in item is equal to asterisk new session in all lowercase asterisk, then I set a variable called finish trials equal to true, and I redirect them to done.php. And the reason I set that finish trials variable is equal to true is that if you look at inside of code, there's a done.php file. At the top of done, it does this. It says if finish trials is not equal to true, it sends them to the Rick Astley never gonna give you up YouTube video. So it rickrolls them if they try to skip. We used to have people who would be in the middle of the experiment and they figured out they could type done.php at the end of the URL and redirect to the last page and get the completion code. So this stops them from doing that. It just sets it so, where's trial? So now when you're on trial, if you hit a new session, that means you're done with for today. We set this variable finish trials is equal to true, and then we send you to done.php. So we basically say stop doing whatever is going on this page, immediately load done.php. And we load done, and done will tell them, hey, you've completed for the day. And that's all. That's the way the new session works. And there's also, actually no, that's it, right? Yeah, that's it. I think at the top there might be something here. Oh, at the very top near, is it line 34 right now? If the item is equal to experiment finished, so what you're not seeing here, on every single experiment, we add this. So this is a multi-session, but assume it's a 1 day, it works the same. So you load a file that looks like this, right? You give it a procedure and does all this stuff. Well, once it's done loading all the procedure and created the experiment, it creates one more line with the item set as experiment finished. So that's a way to tell the program you've completed not just today's session, but every session in the experiment. You're done with the whole experiment. So on a 1 day experiment, it goes here. On a multi-day experiment, it does this. Puts experiment finished there. So at the top of trial, when you get to here, if it says experiment finished is your current item, then it automatically sends you to done. So that's another way of saying you don't need to do any trial types. There's nothing more for you to do here. You're done with the experiment. Sends you to done.php. It shows you your verification code if you're on mturk mode. And that's sort of how we handle multi-session. We load them up on login. If they have a past session, we load them up and then send them to trial. When they get to trial, we first check if they're done with the entire experiment, which is here. If item is equal to experiment finished, that means they've done all the sessions. Or if it's a if it's a 1 day, like a single session experiment, that means they've completed the first session. We send them to done, saying you don't need to do any more. Or we say you finished today's session, so when you're going initially, at some point you'll hit the item that says new session, which means you're done for today, in which case we say, okay, go to done as well. So that's how that's controlled. Get back to Tyson. Wait, Tyson's microphone is off. He's scrolling, though, like he's talking.
Right. I was actually just looking at the comment here. It says skip to done if someone has logged in who has already completed everything. So is this not what submits them to done if they just complete it the normal way?
Yeah, if they complete the normal way...
Does
Actually,
that
no.
happen next?
No, if they complete the normal way, it'll work that way, too, I believe. Or it might happen at next. Let me check.
Oh, right. Okay. So it does happen at next. So
Okay.
if they reach the last trial type and are sent to next, which is where we actually write the data into a file, this is where we set this variable finish trials is equal to true, and then send them the final questions, and from there they'll eventually get set to done. So this line here is important because this is what tells us that we don't need to rickroll this person.
Yeah.
But if they finish the experiment, we still store their data, their session variable, into the JSON file. And if they log back in with their name, we will just send them right to the end of the experiment and give them the verification code. So the idea here is that someone might finish your experiment, get your verification code, and then clumsily close the browser, and rather than make them redo the entire experiment, they can just type in their worker ID again, and they'll get their code. And hopefully no one will be upset with that.
Yeah, it also stops them from running the experiment multiple times, because some people thought, like, oh, this pays pretty well, I'm going to run it 5 times in a row, which for them is nice, but for us wanting clean data, we want them to run once and only once. So they try to log back in again, and it just sends them right to the end with the same verification code saying you're done.
Yeah. Let's see, is there anything else important in trial? We have a bunch of error checks. So like if you have a trial type that doesn't exist, like you make a typo and instead of saying instruct, you leave out the couple letters or something, we'll just spit out a couple of readables for what's going on, and hopefully that'll help you figure out what you need to change. But all this stuff down here is basically stuff that most of the time shouldn't be running, and if it's running, it's just because there's some error. But in terms of how it actually affects your trial types, this is only what happens when things start breaking, so you don't need to worry about that too much. Yeah, I think that's good for trial, and then the more interesting, case-by-case stuff happens within your trial types files. There is a, like Are we demonstrating the merge that I made like just 2 hours ago, or how new is your version of the collector?
Mine's the one that's on the server right now, so it's the newest merge one.
Okay.
Although I think we should hold off because we've probably only got like, I assume we're wearing very thin on people's brains, because my brain is already turning to mush. So
Alright,
we've
well,
been doing this since about 3:15, so I assume we got to be close to.
Right. Well, then just one thing to show. So we have inside code, we have the trial types file, but also inside experiments, there's a trial type file, and this is where you can make sort of your custom overrides for each of them. So here I have instruct, and basically I just added this font size 110%, and the program will first it'll check the trial type inside code, but then it'll also check the trial types inside your experiment folder, and it will replace trial types if they find them. So you can do this if you want to edit some trial type that's sort of basic and supported everywhere, like instruct, and you can change it for just one experiment, and then when you're swapping experiment folders, you would just be reverting back to the default. But we now have 2 folders where you can put your trial types. So this is just another area that you can edit it inside your experiments trial types folder.
It's also really good for sharing experiments between people. So if you are migrating between different versions of Collector, let's say we have a new version that has some new features, you don't have to remember that you modified a trial type, you created a custom trial type inside the code folder. Everything will be contained within the experiment folder, so you can just copy that, paste it into the new version, overwrite whatever the default experiment folder is, and it should just run and recognize that you have a custom version of study, or you created a new trial type, whatever, study left, study right, whatever you needed. So it makes it easier, and it's also easier to remember that you had made trial types custom. Sometimes you might be trying to share things, you're trying to migrate versions, and it'll break unexpectedly because you forgot that you were using a custom trial type that isn't one of the defaults. This is just another way to kind of simplify your life and not have to go into the experiment folder as well as in the code folder when you want to make custom trial types. You can do it all from experiment. So what else should we talk about, Tyson? What happens is, so we've talked about how trial generally works. The one thing we didn't mention is, well, we briefly mentioned it, but I think it's worth hitting again, is that so trial is generally submitting data to itself when you're on the same row. So if you have, trial, then post 1, post 2, trial will submit the data back to trial. The first trial type will say submit to trial.php. We've talked about how we place data into the memory, and then post 1 will run, and that will submit data back to trial again. We'll place that data appropriately with post 2 or post 1 or whatever. When we're out of post trials to run, we don't submit the data back to trial again. Instead, at that point, we submit the data to next.php. So here's next. And next is mainly here just to write the data to a file. That's pretty much the primary function of next. So there's all these columns that we by default have for every single row of data. So we just set an array, we call it data here, and we say username, ID, experiment name, session, trial date. So all the stuff that shows up in every line of data, we say, okay, grab this, plus add the stuff we've been collecting for this trial. So add the post 1 responses, the trial type responses, the post 2 responses, the post 3 responses. Combine all that stuff and then write it to the output file. So write the data to the output file, so that writes that row of data because all those posts go on the same row, so we write the whole row. We increment the counter, so at this point, if we were on trial 3, in memory we change trial 3 to say trial 4 is the current trial we're on. We reset post number back to 0 because we're no longer on a post trial, now we're back on the first trial of the next line. And then we submit, and then we say, okay, now load trial.php. So when trial shows up, now trial recognizes I'm not on line 3 anymore. I should be writing the stuff for line 4. And then it loops on itself until it runs out of things to do for that line. When it runs out of things, it sends to next. Next says, okay, I can write all that data you've got. Writes all the data to your output file, then says, now let's go to line 5. Start at post level 0. And it keeps looping that way until we're out of lines to run. So this sort of trial and next are the two things that 95% of the time you're in your experiment, and this is what you're doing. You're going from trial.php to next. And that's all that's happening. And you actually never see your browser say next.php because we're using this header right here, the header redirect. So technically we tell the browser when you're out of stuff to do on one line, send stuff to next.php. Next.php just writes everything and then says, okay, I didn't send any code, I didn't send any HTML back to the person who sent me this stuff, and I don't send the HTML. Instead, I just redirect them back to trial. So from the perspective of the person sitting at the computer, it just looks like trial is looping on itself forever. But technically, at one point when trial runs out of things to do on its own line, it sends to next. Next writes all the data, and then next says, okay, let's keep going with trial type. And then it just keeps going. And that's pretty much the progression of how you go from trial 1 to the last trial, is bouncing back and forth between trial and next.
Right, and if you're interested in doing additional checks in between trial types, probably you want to be working in the section at the top of trial.php, because that is actually in between post trial 1 and 2 and so on. And since you only reach next at the end of each row, you're not always seeing this page. So if you're trying to manipulate things like that, just keep that in mind, that you only reach next at the end of an entire row, not in between each trial type.
Yeah, so next can't change anything between post 1 and post 2, or between the trial and the post trial, because next doesn't execute until you're done with all the post levels for that row. And then from here, right, it's once we're done. So when next runs out of things to do, and here if the item is equal to experiment finished in next, that means I've run all the items I can, and now I'm at the marker that tells me you're done with this experiment. Then we redirect them to final questions. So I guess it's important to note the only time your participant answers your final questions is when they're done with the final session of your experiment. So in a one-session experiment, that means they load, they go through trials. Let's say you have 10 trials, trials 1 through 10. They do all them, and then they get sent to final questions.php, and then final questions will send them to done. But if you have a multi-session experiment, let's say there's 2 days and 10 trials each day. Day 1, they do trials 1 through 10, and then they get sent to done, saying you're done for today. They don't answer final questions. And then day 2, they log in, do the next 10 trials, and when they're done with those, then they do final questions and get sent to done.php. So however many sessions you have, they'll only get asked the final questions one time, and it's at the end of the last session. So if it's one session, that means the end of the first session. If it's 15 sessions, they'll answer final questions at the end of the 15th session. And if they log back in, it won't ask them again. It'll just send them straight to done after they've answered final questions. That's pretty much the whole flow, isn't it, Tyson?
Yeah, and then it's just once you're done with that, right to done. Final questions just works by bouncing itself between final questions, and then where are we recording it? Is it
FQ data?
Yeah, FQ data.
Yeah, so here I'm showing finalquestions.php. This file's kind of weird and confusing. I wouldn't worry too much. The main thing you're looking at is this. So again, we're looking for the form, and the action is equal to FQ data. So whatever they're responding to, we're going to send the data they give us to final questions data. And here's final questions data. All we're doing is writing pretty much the data they gave us and then redirecting to final questions again. So final questions go to final question data. It loops back on final questions until I believe. Oh, unless there's not unless there's not another question coming up. So here at the bottom of final questions data, it says if all final questions position is not set, all it means is, so here you can say I've incremented the position counter. So we start at position 1, go to 2, 3, 4. So let's say we've just answered the 4th final question. We did it here on final questions. We sent the response to FQ data. We recorded the data. Here it is, array to line data into the final questions data path. So we wrote down the data they gave us. Now we increment the counter, so we're on 5. And then we say, does 5 exist? Is there a final questions 5? If there isn't, then redirect them to done. So that's how we kind of break out of this loop of final questions, is that we keep answering questions, recording data, and then checking, is there another question coming up? When there isn't a question coming up anymore, then we just say, okay, now you're done. Go to done.php. This is stuff, too, that you generally don't have to mess with final questions.php. Like, there's very few places you want to really do much with it. And
I think that basically explains the flow. If you look in your code folder, you can see all the files that we've been working on. But you see plenty of files that we haven't talked about, such as Tinker and So Tetris and Node.js and stuff like that. A lot of these you shouldn't be accessing directly. For example, if you just went to scoring.php, it wouldn't make sense. The program will probably give you some weird errors. But other ones are actually meant to be helper tools for you. So we talked a little bit last time about tinker.php and trialtester.php. So hopefully we'll find a way maybe to clean this folder up a bit. But the files in here, they're worth looking at because you can find some extra tools to help you set up new trial types or just work with PHP a little bit if you want a workspace.
yeah, and lots of the stuff that we didn't talk about directly, it's because, or it doesn't seem like it's part of the flow, it's just that we're using an include to run it, like header and footer and scoring. So it never, we're never directly saying, okay, this sends to scoring. Instead, inside of trial will include scoring when it needs to be scored. That pretty much is the beginning to end, doing everything in collector, which seems crazy that we cover that in 2 hours. I imagine Aaron's brain is probably close to
My
melting.
brain is about to explode.
It's like blood coming out of both nostrils and eyes.
I don't even know half of what I just heard.
Oh, that's worrying.
No. That's why it's good it's recorded.
Yeah. People in the future can be like, what are they talking about? I mean, I think, the code stuff, you can get pretty deep into it, but a lot of it you don't need to touch, ideally. Or at least now you can watch this and be like, where did they talk about that thing? And that's kind of the idea, where the code is happening. But I think once you start digging into it, it's not as complicated as it seems. So should we call it? That's about 2 hours, and
Yeah, I think it's
the most dense 2 hours probably that's ever existed on the internet.
Yeah. There's small changes to trial tester, but nothing, I think, more than what we showed last time. Most of it's just stuff in the code, not even stuff that you'd see. But so I think that's it to show.
Awesome. So Aaron, what we have to do is get you using those triangles inside of this program, and then we can. I think that should be, well, I don't know. Your triangles look really pretty in the program. Whatever you were using, they looked very nice. I was like, whoa, that is professional looking.
Yeah, that's what being married to a programmer.
I know, that's a pretty awesome ability to be like, make it look like this, doodle a thing and be like, that's what I want my webpage to look like.
Yeah, he took it way beyond. I was like, just make it a triangle. And he's like, no, I'm going to make it look pretty. I was like, go for it.
See, now you have to get him to make that a trial type in here, and then you can do a lot more experimenty things and just be like, yeah, record this and that.
Yeah.
Alright, I say we take a week-long coma break from talking about code. Cause I don't know how useful this is to people. Hopefully, in future generations, we'll unearth it and discover its usefulness, or we'll radically change the code again to the point where it's not the stuff we're talking about anymore. Then it'll just be a mark of the shameful attempt to teach people while we built a tool around them.
Yeah, in a month I'll completely redo trial.php again. None of this will be relevant.
Oh, Tyson. Alright, guys, that's turning off our broadcast so we can begin cursing again.